안녕하세요. 안녕하세요. Thank you very much, and welcome to Discovery Summit Korea. I am very pleased to be here. I'm Jeff Perkinson. I am responsible for user enablement here at JMP, and I will be your host. Thank you very much, Min Chul Hee, for the kind words of introduction. This is Discovery season. About 3 weeks ago, many of us were in Austin, Texas for Discovery Summit Americas. Just last week, we were in Tokyo for Discovery Summit Japan. Of course, we're here with you today, and it's kind of a sad event because this is the last Discovery of this Discovery season. But you are in for a terrific day full of opportunities to explore how you can build your analytic culture, how you can use JMP to solve your problems more efficiently. At JMP and JMP Discovery, we believe in the power of questions. Questions like, what if we trusted data as much as we trust our instincts? Or what would change if every decision started with a question? Those are the kinds of questions, the opportunity you have today to explore those answers, to ask and answer those questions. Whether it's from plenaries, like the one we're going to start with from some of our R&D experts to show you some things in JMP 19, whether it's from this morning's other plenary, from a distinguished expert at the intersection of statistical insight and AI. We have papers from JMP users just like you. We have some of our staff delivering papers showing you how you can use JMP more effectively and efficiently, some of the new features and exciting ways that JMP can make you a better practitioner. Of course, we have our Meet the Experts stations right outside these doors. We would love to greet you there, answer your questions, learn how we can help make JMP better for you. And of course, there's lots of opportunity for you to connect with each other. That's what lots of discovery is all about. Meeting other practitioners, meeting others who are on a similar journey and getting to know them and understanding how they're solving their challenges and how you might be able to use that to solve your own. Now, this is truly a global gathering, very international. We have brought a tremendous amount of staff from overseas. We know that many of you, English is not your first language. We have translators available. We would love to engage with you. We want to meet you. We want to understand how we can help you. I'd like to ask our international staff to please stand for a moment so you can see them. You will know how to seek them out. So if you wouldn't mind, stand for just a moment. These people want to know you. Please reach out, engage with them, and let us know what we can do for you. Thank you all very much. JMP is all about data exploration and what we can see in the patterns in our data. I'd like to take you through a slightly different visualization exercise if you would indulge me for just a moment. If you feel comfortable, I'd like to ask you to please close your eyes. And as you sit in stillness for just a moment, think about a problem that faces you back in your office. Perhaps it's some messy data, an unstructured set of data that you need to clean up. Perhaps you've got a slow project or a tough decision. Picture that situation and now gently place it on a shelf beside you. Maybe it's right up over your right shoulder. Just place it on that shelf. We're not getting rid of it. We're just setting it aside for a moment. Now, imagine when you go back to work tomorrow or next week with new ideas and some fresh insights that you're able to share with your team and help to solve that problem or problems that sit on that shelf. You begin to see solutions where once there were only problems. Now, slowly open your eyes. That is the opportunity you have today. Take this opportunity to engage with those ideas. Prepare yourself to go back to work tomorrow or next week with those fresh ideas and be able to share them with your teammates. So for the rest of the day, I invite you to be fully present and engage with all of that. So thank you very much for participating in that. In just a moment, I'm going to ask you one more indulgence. A big part of discovery is, as I said, getting to know each other, connecting with your fellow attendees. So I'm going to, in just a moment, ask you to stand, find one person that you do not know, and introduce yourself, perhaps give them a brief introduction to the problems that you were thinking about in your visualization, and then we'll sit back down and we'll get to today's plenary. So I'm going to give you 30 seconds, and I'd like for you to stand up and find someone you don't know to introduce yourself to. Go. Okay. Very good. Thank you very much. Thank you very much. I hope that you will continue those conversations over the course of today and into the coming weeks. Perhaps you're exchanging contact information and you can continue those conversations. Later today, I'm going to tell you some other ways that you can continue those conversations. Thank you very much for participating in that. And I think it's time that we should get to our first plenary. This plenary is all about seeing things differently, because the challenge the journey from challenge to solution begins just that way, seeing things differently. Our challenges today require flexible, scalable tools, not local solutions. Our guide on this journey will be Jules Parris, and I invite you to stay fully engaged and welcome Jules to the stage.
Good morning, everyone. I'm really glad you're here with us. I'd like to ask us to start by imagining something together. I'm wondering if, with me, you could imagine an engineer at their desk analyzing complex data. Now, while we're imagining this, I'm also going to ask AI to imagine with us. I'll ask an engineer analyzing data. He doesn't look too happy, does he? Clearly, he's not a JMP user. Now, when we talk to engineers, we hear about a lot of challenges they tend to have. And this may just be the imagination of artificial intelligence, but because AI is trained on our world's images, it reflects some of the beliefs of this world. It also reflects some of the biases of the world, but it probably reflects some of the truth of the world as well. So if you'll indulge me, I'd like to speculate on what is making this person's day so bad. First, it may be that he's thinking that this is not his job. He wasn't hired to analyze complex data, but now it's a part of his everyday. He may also be thinking that it requires others. He depends on people, and oftentimes those people don't so much care about his work because they're busy doing their own work. He may also be thinking that this work is too complex. This isn't what he was trained to do. He maybe didn't even go to school for statistics or data analysis, but now he's being asked to do this work. Or he might be thinking that this work is too monotonous. He's doing the same thing every day, and it's frustrating to have to do the same thing over and over. Now, this is just speculation, but these are the kinds of challenges and frustrations we hear when we talk to engineers analyzing data. And it's what we think about when we build our versions of JMP. Now, every version of JMP, we think about these challenges and how we can make data analysis faster and easier. Over the last few versions, we've put a lot of effort into parts of the analytic workflow that are typically associated with data science. Things like data import using data connectors, things like large-scale analysis, things like workflow and automation, scripting that lets you reduce the monotony. But in every part of JMP, we've looked for places to make data analysis not just more efficient, but also just easier. Because how we analyze data is not just about having a feature that makes it possible, it's about doing so in a way that makes you want to analyze data in a way that doesn't make you frustrated. And so part of the magic of JMP is not just that it enables complex analysis, it's that it makes it approachable. And so today, we're going to hear a lot of stories about the things that make JMP magic, the things that make JMP useful for our type of analysis for engineers. And so to start us off, I'd like to invite Valérie Nedbal to the stage to show us one of the ways that JMP is magic. Valérie?
Sorry. Okay, so let's do that again. So I'm very happy to be here, and I hope you too. So my presentation will essentially focus on screening, and more especially on response and process screening. Those two platforms are very powerful in a sense that it can handle very large amounts of data for different purposes. And I will show you some examples in my presentation. First of all, I will show you response screening. Response screening comes with two flavors platforms. One's in the screening menu, the response screening. It fits y by x for many pairs of y's and x with grouping, and subgrouping and JMP 19. The fit response screening is actually a personality of the fit model, and it fits y by a model of x for many, many y's. In JMP 17, we introduced the switch mechanism. In 18, the random effects. And in 19, what I will show you today, two new options, slicing and subgrouping. The common features of those two platforms is it can handle many y's, many groups and subgroups. It's threaded for high performance, and it's calculating false discovery rate adjusted p-value, or FDR, and log worth. It's essentially log 10 p-values. In order to demonstrate your response screening, I decided to choose a data that is related to my scientific background. So my background is molecular biologist, and I was always very curious and interested to understand the outcome of diseases and risk factors that are related to. So I decided to choose a data, diabetes type 1. The data looks like here. It's a quite rich data, about 19,000 or more than 19,000 rows. And the incidence has been measured over 30 years in different locations, in different continents, in different age groups, and different gender. So my first question was, which of those factors are driving the incidence? So a very easy way how to do that visually is using the graph builder. Here you can see in the graph builder on the x-axis the 30 years, and on the y-axis the incidence. And I have split it, each of those, by the age groups and by the gender. And what you can see, first of all, are the differences between the younger and the older people. you can also see a growing trend year over year in all the different locations. And you can see all those lines represent one particular location. So we are here in Korea, and the closest match for Korea was the East Asia. So let's see what is the incidence here in Korea. And you can see that the incidence is quite low compared to all the different locations. I'm located in Germany, so in Western Europe. So let's have a look where Western Europe is. And you can see there is a quite huge difference between here and Western Europe. So my next question was, or are those differences really significant? Can I actually slice those different variables into the levels in order to see if I can see significance between the levels of the variables? And this is where the response screening comes in play. I will use the fit response screening for this. I'm using here in the fit model, and you will see here in the personality at the very bottom the response screening. I will use the incidence as my Y. I will just use the age group as my effect terms, and also the gender. And what I will do actually an interaction between the age group and the gender. Because I would like to see if I can see within the age group or within the gender differences of the other variables. So before doing that, I will explain you a little bit what I will do. So we have here the gender and the age groups. And what the slicing will do will actually slice all my variables in those different levels. So I will be able to do some comparison within one variable for the different levels. So that will be the case for the gender, for the age groups, but also within the gender for all the different age groups, and the other way around for all the different age groups, or within the age groups for the different gender. So what I will have is 36 different combinations. So let's go back to my fit model, and let's run the analysis. So first of all, for people who have already used the response screening, this is what you see is actually the effect for all the variables, so age group, gender, and also in the interaction. So no surprise, everything is very significant, because we have seen that in the graph builder. But now, the magic comes here with the slicing. So this is the sliced LS means, and that is what I have referred to the 36 different combinations. So what we see here is a graph that represents the FDR log worth, or the significance, with the LS mean differences. So everything what's high is very significant. And I can mouse over and then see what is the term or the combination that is highest significant. This is actually within or between the older and the very young age groups. I can also use here in this little legend, I can select and interactively see visually all the different combinations of the age groups, the gender, within the age groups, the gender, and within the gender, the age groups. But more particularly interesting is actually now to see one by one all the 36 different combinations. And we can see here, for example, everything what's red is very significant. And we can see here one combination that is or the highest significance is between the older and the younger people. So let's imagine that we have now all the locations. We have about 50 different locations. And if I'm using now the 50 different locations as a subgroup variable and doing the slicing in combination, it will do for each location the same comparison. So it will do 50 times 36 plus 36 for other location. So it will do 1,836 different comparisons. And again, I will show that here in the fit model. I will do a recall, but now using the location as my subgroup variable. And you will see I run the analysis, and instantly I got here my answers. I have first all the effects, but what I'm interested in is using the slicing in combination with the subgroup. And now I get here the same type of graph, but of course with much more comparisons or combinations. I can see here where East Asia is, and we can see that it's quite low compared to all the different locations. And again, you will see here all the different combinations, 1,836 different comparisons. So very powerful. Let's change gear for a moment and talk about what is new in process screening, and more especially on environmental monitoring. Environmental monitoring is a visual and statistical approach to detect, monitor, and prevent contamination in manufacturing. And this is especially critical in pharmaceutical and semiconductor, where a thin contamination can compromise product safety and quality. Let's imagine the following situation, where I have here a floor plan where I can see all different locations of my clean rooms. And I can see from day to day their contamination measurements. And I could see, for example, in one particular day, if I have in one room quite critical amounts of contamination. I can mouse over and then see their respective control charts. So environmental monitoring comes usually with count data. And before JMP 19, process screening only handled normal processes that monitor whether a process was near its target. Now in JMP 19, process screening can handle non-normal processes. And it will apply automatically the best fitted distribution using the AIC for count, for non-negative continuous, and for proportion data. It will also set automatically alarms for 2 sigma for alert limits and for 3 sigma for action limits. You can also use custom limits based on historical data. And you will also follow rules like 2 alerts in a row when you have increasing contamination. So let's have a look. I have again the data. Again, data is quite huge, about 7,000 rows. And the count of contamination has been measured over time in different sites, different grades, and different types. I will use now the process screening that is under quality and process. Let me do that bigger, and you will see here in the drop down for control chart type 3 new distribution types or non-normal processes for count, non-negative continuous, and proportion. I will use the count data, and you will see automatically that options for alerts like action and alert limits will be populated. I will use the count for my process, the time for my time, and I will use here all my different variables, my grouping variables, as my grouping. I will run, and again, very, very fast, I will get here my answers. Do I have contamination or problems in some of the rooms? And you can see here are all my different grouping variables, and you can see here the alert rate, the alarm rate, and you can see here that we have 6 rooms with particular problems, where I have in four of the rooms action limits, and also alert increasing in 2 of the other rooms. I'm going now to the red triangle and then use show control chart as selected, And that will enable me to see the control charts of my 6 different rooms. I can also use in the options the alarm graph, and that gives me maybe a better sense when those particular contamination occurred. I have here my 6 rooms, and I can select again some of the rooms, and maybe particularly those 2 rooms where they are really close together in time, that could maybe mean a cross-contamination problem. So if I wanted to share this particular report to people who has no JMP, I can use what we are calling JMP Live. If you want to publish to JMP Live, you can go here in the red triangle of the file, and then go to publish, and then publish to JMP Live. I have done that already, so I have here the report now in JMP Live. So essentially, it's exactly the same report, but now in JMP Live. And exactly what I have done in my JMP, I can select those particular rooms and then see their respective control charts. So what I've showed you today are 3 different options, or 3 new things. 2 in the response screening, that is the sliced LS means, and the subgroups. And in the process screening, now it can handle non-normal processes. So thank you very much for your attention. And with this, I will pass over to Jules.
Thank you, Valerie. I'm always so impressed at how fast JMP is for these huge analyses. 1,836 analysis in just a second. So impressive. The systems that engineers are always trying to work with, though, are not always that easy and require specialized knowledge. And because of that, there's the dependency on others to get work done. So part of the magic of JMP is not just the analysis it enables, but also the steps that it can eliminate. And so to tell us a little bit about this, I'd like to invite Sarah Gilyard to stage.
Hello, my name is Sarah Gilyard. I am on the product management team at JMP. Prior to joining JMP, I spent 16 years in the semiconductor industry. Semiconductor fab can often be a very chaotic place. Fab engineers will spend a lot of their day jumping from one crisis to another. So what I would like to show you today is how JMP and the Workflow Builder can help make the life of a fab engineer just a little bit easier. And to motivate this discussion, I'm going to use data from a very common semiconductor process called shallow trench isolation. During this process, trenches are etched into a silicon substrate using a plasma etching process. Sometimes that etch process will have to remove additional films like oxide or nitride prior to entering into the silicon. However, once those trenches get completed, they'll be filled with an insulative material in order to electrically isolate different circuit components. So the problem of interest in this particular case study is that the depth of the trench that we are etching into that silicon substrate is exhibiting excess variation, and as a process engineer, we need to be able to quickly source where that excess variation is coming from. So let's go ahead and go to the workflow. So this is the workflow, and it's a relatively simple workflow. However, engineers have to use a lot of discretionary judgment in their day-to-day job. So it's very important that any workflow be able to reflect that. This workflow could also easily be modified to apply to other processes and be shared across an organization. So I'm going to go ahead and run the workflow to show you what it does. So let's run this. So the first thing that the workflow asks me to do is open my data table. So I'm going to open my data table. And you'll see that the workflow opened my data table. My data table includes data from multiple lots, multiple wafers within each lot, and multiple sites on a wafer. And the first piece of analysis that's performed is a variability chart, which also includes a variance components analysis that you can see down here at the bottom. So the purpose of this step in the workflow is that semiconductor manufacturing involves a lot of batch processing. So for example, a plasma etching process will run a single wafer at a time versus something like a diffusion process will run up to 125 wafers at a time. So this will produce some very complicated variation structures in the data. And it's often helpful for a fab engineer to break down the overall variation into its batch components to help source what tool set or what process the problem might be coming from. So that's what this piece of analysis does. Down here at the bottom, you'll see the variance components broken down by lot to lot, wafer to wafer, and within wafer variation. So the bulk of the variation in this case is coming from lot to lot variation, so about 55%. And you'll see a message popped up here asking me to review this variability chart and then click continue when I'm ready to proceed. So I've reviewed it, so I will click continue. So the next thing that the workflow asks me to do is decide how I want to aggregate the data based on the variation breakdown that I just performed. So in this case, since the bulk of the variation is lot to lot, I'm going to go ahead and aggregate at that batch level. So lot is already selected. However, you could also choose wafer, within wafer, or perhaps you want to go ahead and just do all. I'm going to leave it at lot and click OK. So the workflow just performed quite a few steps. So we'll go ahead and see the analysis that we've performed. So the first thing that happened is that the workflow aggregated my data table, my original data table, to the lot batch level. So now each row of the data table represents one lot. This is so that I can perform my data mining at this batch level, since that's where the bulk of my variation was happening. And we get a first piece of analysis is an SPC chart, a control chart, showing that, yes, our process is out of control, and we need to source why. Next piece of analysis is a bootstrap forest. So a bootstrap forest is a very versatile and robust data mining technique. It handles outliers and multicollinearity very well. This particular analysis had a little over 30 input process variables. And you can see from the bootstrap forest analysis that the top two process variables that are contributing to my variation are a film roughness variable and a nitride film thickness. So this could suggest that we have an incoming film problem. And then the last piece of analysis that the workflow performs is just a graph builder with a column switcher to allow me to quickly review my process trends to make sure that everything behaves physically the way that an engineer would expect them to. And last but certainly not least, the workflow will publish all of this data out to Jump Live so that you can share with your colleagues all of this great work in about 10 seconds. So thank you, and I'll go back to Jules.
Thanks, Sarah. Building an adaptable workflow like that is such a great way to reduce monotony in our own work. I also love that it allows for an engineer to share their specific knowledge with others to enable them to do the analysis on their own. But part of the magic of JMP is not only the kinds of steps that it helps you eliminate, but also the kind of work it can help you avoid altogether. And so to tell us more about how this is going to work, I'd like to invite Mia Stevens to the stage. Mia?
Thank you, Jules. So, hi, everyone. My name is Mia Stevens. And like Valerie and Sarah, I am a member of the JMP product management team. And my background is a little different. My background is Six Sigma training and consulting, and also statistical education. Now, JMP is built in a way that lets you extend what you can do beyond features and functionality that are natively available in the software. And today I'm here to tell you about the JMP Marketplace and how extensions on the Marketplace can help you streamline, enhance, and customize your JMP workflows. Like Jules said, you can just remove some of the steps altogether. So how does it do this? With Marketplace extensions, you can bring your data from various data sources into JMP. And you can access out-of-the-box data visualizations, analyses, and integrations to help you streamline your analysis workflows and processes. So let's take a look at the JMP Marketplace and how we get extensions from the Marketplace into JMP. All right, sorry about that. I seem to be very special when it comes to mics and connections. All right, so here's the JMP Marketplace. And the Marketplace has featured items and new extensions. And you can simply browse the Marketplace. And let's say we're interested in importing data into JMP, data connectors. Now, there are many data connectors that are built into the software. So if you're in JMP and you go to File and Connect to, there's a data connector framework where you can configure your own data connectors and share them with others. Or you can use ODBC. And you can also connect to Aspen-Tech or Pi servers. But if a native data connector isn't available, you can likely find a connector in the Marketplace. So these are connectors that are available in the Marketplace. And let's say I'm collaborating with some colleagues and we have data stored in SharePoint. To use this extension, I can simply download it and install it, and it's available to use whenever I need it. And then the next step might be to visualize my data. At this point, there are 37 visualization tools that are in the Marketplace, with more added every day. One of my favorites is called the Process Capability Explorer. So let's say you're doing a process capability study, and you would prefer that your results show in this format. So I want a 6-graph summary rather than the default format in JMP. Rather than building this yourself or building your own add-in, you can simply download this from the Marketplace. So let's see how to do that. I'll click the download button. And it takes me to some terms. I simply check and hit download. Okay. And there it is in my downloads. And when I install it, if I go over to JMP, here it is in my add-ins menu. And then I can simply launch it whenever I need to use it. So let's take a look at an example. So I've already set up a data connector. I've installed the OneDrive and SharePoint data connector. I've configured it and called it Mia's SharePoint. And there are two data sets. I'm collaborating with some colleagues on these data tablet measurements, and I'd like to open them. I can either use the query builder, or I can open directly in JMP using Open Table. And here are the data. Right? So I don't need to do that every time. It's sitting there waiting for me when I need it. Now, let's say I'm interested in doing a capability study for a variable, say the variable weight. I can simply launch the add-in. And part of the beauty of add-ins is that you can customize launch dialogues with whatever you'd like. For this one, I'll simply use the defaults. I'm going to look at weight and click OK. Okay. And there's the analysis, right? Now, there's lots of customizations here. One of my favorites is this slider here, where I can slide back and look at previous observations. This was actually added into Control Chart Builder recently. Right? But there's lots of other functionality that the add-in developer built into this. So for example, if I want to see very quickly if there are any out-of-spec points, I can simply color out-of-spec. Okay. I can pick a color, click OK, okay, and then I can quickly see points that are out of spec. Okay, all of these points here are out of spec. So while the process appears to be stable, it's not very good at meeting customer expectations. And now if I want to be able to share this with others, I can simply publish this to the marketplace, as you saw earlier with process screening and with the workflow that Sarah shared. Another great category of extensions on the marketplace are actually Pythonic add-ins. So these leverage the power of open source Python libraries to do analysis directly in JMP without having to write any code. And that's part of the beauty of this. How many of you like to write code? It's a few hands. Melanie, you don't count, right? If we can access extensions without having to write code, it's very powerful and a great time saver. Two of the most popular add-ins developed by Russ Wolfinger. Where's Russ? Right, there he is. You'll want to know him. Are XGBoost and the Torch Deep Learning add-in. So these are extremely powerful, and these are on the marketplace. And they're in the category machine learning. So if you look on the marketplace under the categories, there's a machine learning category. And there's also a new extension called the JMP Assistant. The assistant provides a natural language interface to JMP in a familiar chat style format. So you can pick your data, your large language model that you want to use, even if you're behind a firewall, and then you can ask it a question. It will write JSL, and then it will perform the analysis in JMP. So this is an early prototype that's on the marketplace. We have an exercise on one of the Meet the Expert machines. If you want to give this a try and give us some feedback, we call it the JMP Lab. So please try it out if you're interested. And Russ is also giving a talk on the topic this afternoon. Now these are some more advanced add-ins, but there are also a lot of extensions on the marketplace that are at the beginner level for users who are either just learning JMP or are learning new methods in JMP. So for example, the LearnBot. And I think I showed the LearnBot last year if you attended. This is one of my favorites. This is a chatbot that installs under the help menu, and it helps you learn how to perform very basic tasks and analysis in JMP. So it's trained on our documentation, it's trained on the STIPS course, other learning resources, our scripting index, and you ask it a basic question like, how do I do regression in JMP? And it comes back with a very nicely formatted response with links on how you can learn more. Another favorite is the Data Analysis Director. So this, which I'd like to refer to as DAD, is like a recommender system. You can ask it questions, and it guides you through your analysis. Now, some of the extensions on the marketplace are localized, like the LearnBot, and others are in the process of being localized. And the marketplace is open to submissions from JMP users. So if you have some interesting add-ins in Korean, that you'd like to share with other users, the marketplace is open to submissions. So there's so many exciting extensions already built that you can use to customize your workflows. So we encourage you to see what you can find in the marketplace to help you streamline, enhance, and customize your analyses. And with that, I will hand it back over to Jules.
Thank you, Mia. We've seen this morning that the power of JMP, the magic of JMP, is what it enables, what it encourages, what steps it helps you avoid, and what work it helps you avoid entirely. But I think there's one more thing that makes JMP magic across the entire analytics workflow, which is it's how JMP makes you see yourself. Because I think how software makes you see yourself is so important because it dictates how bold you are in the software. You saw this with Valérie. The software helped her feel powerful, so she was encouraged to explore interactively. How software makes you see yourself has a big influence in what you choose to do in it. There's an interesting effect I want to tell you about in the psychology literature. It's called the Proteus effect. Now, Proteus in Greek mythology was a sea god. Proteus could take on many different forms, and depending on the form he was in, he would behave differently. Now, in the virtual reality literature, the Proteus effect describes the fact that how people show up in a virtual space influences their behavior. For example, imagine we're all about to play a virtual reality game, and some of you are given an avatar that's really tall, and some an avatar that's really short. It tends to be the case that people who are given the taller avatars are more outgoing. They're more social. It affects how they show up in the virtual reality space. And this has been concluded in many meta-analyses. There's a lot of research behind this. And it's maybe not that surprising. Think about how we show up in the real world. How we look influences how we behave. Now, I think this also shows up again in software. How we feel using a piece of software influences how bold we are. And I want to end by giving you an example that I was playing with recently where JMP made me feel really bold. And so the situation was, I'm coming over to Seoul and Tokyo for this conference, and I have a friend in Toronto who wondered what the weather was going to be like. The easy answer would be to go on Google and search for the weather in Seoul in November. But I don't like easy answers. I would rather have a much more complicated answer that uses data. So I went looking for data. On Kaggle, there's this data set that has, for 100 different cities, hourly data on weather for the last 5 years. And so you can download these data. They're easy to get. Here's what they look like in JMP. So it's 4.6 million rows. And it has for every city in the data table, for every hour since 2020, the temperature along with many other variables. So I want to use this data set to help answer this question. Specifically, what month in Toronto is most like November in Seoul? Okay, so here's how we're going to do it. I'm going to get rid of some of these extra columns first. I'll get rid of everything other than temperature. And what I'm going to start by doing is by making a couple new columns. I'm first going to make a column for the month of the year. And so I'll use this new formula column, month abbreviated. So this will make a column for me that pulls the month out of that date. I'm also going to make a new column that pulls the hour of the day from that date. Because what I want to do is look at the profile of the temperature throughout the day. So I'll do new formula column, and I'll pull hour. Now, before we go forward, I need to make a new column that is a city month, a column that identifies the month and the city specifically for each row. So I'll take city name, I'll take month, new formula, and do a concatenation with a comma. And just to keep it short, I'll rename that column city month. Okay, we need to restructure the data a little because we have, again, 4 million rows every single hour across every year since 2020. I'll use table summary. We're going to make a summary table. I'll use my city month as the group, so you can see the table as I'm starting to build it. I'll take temperature, and I want the average temperature for every hour of the day for every one of those city months. I'll make the column the header, so temperature at 0, temperature at 1. So this will be for every hour of the day. So here's that table. That is a lot of decimal places for every one of those columns. So I'm going to use Columns Manager and make a quick change. I'll take those columns, set their decimal place to 0. Much better. I'm also going to change their name. I'll recode those column names. And what I'll do is I'll replace the string temperature with nothing. That way, it's just the hour of the day. I'll actually make the columns a little shorter so we can see the full day. I'm going to use a new feature in JMP 19, which is a column tag. I'll use a tag that is for temperature in Celsius, because this tag also has a color property, so that we can look at almost a little heat map of the temperature throughout the day. So for example, let me filter the table down to Seoul in November. This is the average temperature profile for the day in Seoul. So that's what we're going to look for. What in Toronto is most like that? Before we go on, I want to give us one more visualization of the temperature profile. I'll take those columns and use an add-in that I'll probably put on the marketplace soon to make a spark line, a little graph inside the table for the temperature profile. And what that will build, you'll see it at the left-hand side of the table, is a little graph that shows us the temperature profile for every city month. And so if I scroll, you can see that reflects the time of day effect. Okay, so now we have to use some statistics. I don't want to go looking for what city month is most close to Seoul in November. I'll use a cluster analysis. Clustering, hierarchical clustering. I'll use the hours of the day as my columns, and the city month is what I'll label by. This is called a dendrogram. This is every city month in the data table, and the closeness on the tree is how similar their temperature profiles are throughout the day. So closeness here is closeness in those city months in terms of temperature. What I'll do is I'm going to release the zoom and save a table from this analysis, which gives us a matrix of how close the city months are to each other. And so if you think about what this is showing, Abu Dhabi in April versus August is very close, December, February. For every city month against every other city month, we're seeing how close they are. I'm going to restructure the table. I'll do something called a stack, because what I want is the table to be tall, not wide. And I can minimize that table. I'm also going to sort the table. You'll see we have a lot of zeros. In the matrix, those are the city months against themselves. We don't need those, and I'll remove them from the table. Now we're almost there. I'm going to bring back this temperature profile so we can see it for both city months, the left and the right-hand side. To do that, I'll use something called a virtual join, which was added to JMP many versions ago. Basically, I can link that table and tell this column to pull the data in from that other table so that I can have this profile in the table here for Leeds in September or for Manchester in September. I'll do the same thing for the other city so we can compare. I'll bring that in. And again, I will unhide the column so we can see it in the data table. Okay, we're so close to answering our question. This table shows us for every city month against every other city month how close they are. So I'll filter now to only Seoul on the left-hand side, and I'll do Seoul in November. And so we're looking at every city month compared to Seoul right now. The closest across the entire data table, it looks like, is Milan in February. That is the most similar temperature profile across the entire table. The least similar is Kuwait City in July. I think that makes sense. We're almost there. We're going to ask the question now for Toronto across the entire year. What's the most similar? And it looks like Toronto in April has a temperature profile that is most like here in November. And so this was a really complicated way to answer a simple question. But I think it's a fun way to do it. And the point here is not that this is a good analysis. I think it's kind of fun. The point is that JMP makes me feel bold enough to have the audacity to do an analysis like this because it's fun, because the software makes me see myself as powerful. And I think that's one of the biggest things about JMP that is so magical. It's how the software makes us see ourselves. Because engineers, I think, don't often see themselves as so powerful with data. When we asked AI at the start to imagine this person, there's a reason that it imagined him being a little stressed out. But I don't think it has to be that way. Even with AI, we can ask for him to feel empowered, a little bit more empowered. Let's keep pushing on this. Let's ask for him to feel even more empowered. Now he has a lot more screens, which I guess is empowered if you're an engineer. I'm going to say we're on the right track. Let's keep going. Much more screens. Eventually, we're going to have to let him see himself more different, see himself more powerful himself. Here he is at the center of his data universe. He's almost there. Let's ask for the ultimate power for a data analyst. There he is, the center of his data universe. Now this is a JMP user, right? Seriously though, I do hope, and it's I think our job in JMP research and development, to build software that makes you feel this way, that makes you feel powerful with data. Because when you feel powerful with data, you want to analyze, you want to explore, you want to use the software to find answers to your questions rather than just accepting what you already know. And so I want to end with this question for you. How does JMP make you see yourself? And if it doesn't make you see yourself that way, let us know, because we want to build software that helps you feel that way. Thank you so much, everyone.